Alright, so we're continuing with our video, and in part 2 of the video we would have looked at humidity and the formula for calculating absolute and relative humidity. So now we're going to be looking at a few examples to get our practice together. So this question says the mass of water vapor in a 1.5 cubic meter volume of air is 18 grams. Calculate the absolute humidity of this air. And of course, you know that you guys are bright sparks, so you'd have already calculated and figured out the answer already. But we're going to, check up your answer with what we have here. So of course, we look at the formula, which says that for absolute humidity, we're going to have the mass of the water vapor in the air divided by the volume of the air. So in this case, it's going to be 18 grams divided by 1.5 cubic meters. And of course, we're going to be left with 12 grams per cubic meter. So this is the raw data in terms of the saturation state or the humidity of the atmosphere. Now let's jump to this question. It says the partial pressure of water vapor in the air at 25 degrees Celsius is 1.5 kilopascals. The saturation vapor pressure of water at this temperature is 3.17 kilopascal. Calculate the relative humidity. So of course we jump to our formula, which says the actual vapor pressure should be divided by the saturation vapor pressure, and we multiply it by 100%. Why? Because remember, for relative humidity we're going to be calculating percentage, right? So in this case we're given 1.5 as a partial pressure component here, and we're going to divide that by the saturation pressure given, which is 3.17, and we multiply that by 100, as you can see down there, and we're going to be left with 47%. So that's the saturation state for this scenario. So now we are jumping into weather, but in this case with weather we're going to be looking at wind patterns or wind systems across the globe. So of course, global winds are large-scale air movements that circulate around the Earth, and they are influenced by several factors such as the heating of the Earth, movement of the Earth, and different elements of weather. So of course, the Earth's rotation, it causes an effect which most of you should be familiar with based on what we'd have looked at in previous classes, and this concept has to do with the deflection of winds to the right in the northern hemisphere and to the left in the southern hemisphere. And of course, this concept is called, drumroll please, Coriolis effect, right? Good. So we're continuing on the global wind patterns. Of course, there are three major ones. We have the trade winds, which blow from east to west near the equator. We have the westerlies, which blow from west to east in the mid latitudes. And we have the polar easterlies, which blow from east to west near the poles. So when we look at these global wind patterns, these winds tend to influence weather, ocean currents, and climate patterns across the globe. They also help with the distribution of heat from the equator towards the poles, and they are quite vital in terms of navigation, aviation, and understanding storm development. So when we go back to colonization period, these wind systems and ocean currents were quite important in terms of navigating sailors to whichever direction they wanted to go. And of course, we see them being important, especially in storm development throughout the Caribbean. That's our region. When it comes on to tropical depressions, waves, storms, hurricanes, right? So these wind patterns are quite important. And of course, that's a diagram, but I'm not going to show you it, right? So for the next class, please ensure that you read up on these wind patterns and ensure that you understand a diagram, because you should know how these are aligned globally. All right, and that's it for class.